Hey guys, this looks like a fun one. It's the sum of the first 216 terms of this right here. 1 over the cube root of n squared plus the cube root of n times the quantity n minus 1 plus the cube root of the quantity n minus 1 squared. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. So we got to do this for n equals 1, n equals 2, n equals 3, n equals 4, all the way to 216. For n equals 1, we're going to plug in 1 for all the n's. And we're going to do the same thing for all the other numbers. We're going to plug in 2 for all the n's, 3 for all the n's, 4 for all the n's, 215 and 216 for all the n's. Now we can clean this up a little bit. The cube root of 1 squared, this is all just going to become 1. And then inside of this parentheses, 1 minus 1 is equal to 0. And same thing inside of this parentheses, 1 minus 1 is equal to 0. Well, all of this is going to become 0, and all of this is going to become 0, so those can go away. We end up with 1 divided by 1, which is equal to 1. So for n equals 1, we got 1. That wasn't too bad. Now we can try n equals 2. 2 squared is equal to 4, and then inside of each of these parentheses, 2 minus 1 is equal to 1. 2 times 1 is equal to 2, so that leaves us with the cube root of 2, and then the cube root of 1 squared is equal to 1. So now we have 1 divided by the cube root of 4 plus the cube root of 2 plus 1. We can do the same amount of work in this to give us 1 over the cube root of 9 plus the cube root of 6 plus the cube root of 4. And we can do it again and again and again. Now this symbol means the sum of all these terms. So we have to add this plus this plus this plus this plus all of these all the way up to here. We're basically only going to be able to do that if we have a common denominator. I have no idea what the common denominator for all these would be. I imagine it would be humongous. There's got to be a better way to solve this. Let's see if we can find a shortcut somewhere. First, let's copy all this down, but I want to rewrite the denominator differently. Using these notes, we can rewrite the cube root of the quantity n squared as the quantity cube root of n squared. And then we can do the same thing over here. We can rewrite the cube root of the quantity n minus 1 squared as the quantity of the cube root of the quantity n minus 1 squared. And then for the middle term, using these notes, we can give each of these their own cube root. So it's cube root of n times the cube root of the quantity n minus 1. Now inside of these parentheses, we have 2 of the cube roots of n and 2 of the cube root n minus 1s. Let's simplify this with some substitution. Let's let a equal to the cube root of n, and let's let b equal the cube root of the quantity n minus 1. Now using the substitution, we can rewrite this as 1 over a squared plus a times b plus b squared. Let's smush everything together and look at our clean version now. A squared plus ab plus b squared reminds me of something. This is a factor of the difference of two cubes. Anytime you have a cubed minus b cubed, that's equal to the quantity a minus b times the quantity a squared plus ab plus b squared. This is this. So we have an opportunity to clean up the denominator quite a bit. Let's multiply top and bottom of this by a minus b. On top, we have 1 times a minus b. It's going to give us a minus b. But on bottom, we're going to have all of this times this, which is going to be equal to a cubed minus b cubed. Now we can see if this helps at all. Let's resubstitute our original values in the place of the a's and the b's. In the place of this a, we can re-plug in the cube root of n. And then we're going to subtract from that b, which is equal to the cube root of the quantity n minus 1. And then on bottom, we're going to have a cubed, which is the cube root of n cubed, minus b cubed, which is the cube root of the quantity n minus 1 cubed. Now we can clean up the bottom. The cube root of n cubed, this cube root and this cube can cancel each other out, leaving us with n. And then for this one, this cube root and this cube will also cancel each other out, leaving us with n minus 1. Let's smush everything together and distribute this negative to each of these, giving us negative n plus 1. This positive n and this negative n will cancel each other out, leaving us with 1 in the denominator. And this divided by 1 isn't changing anything, so we can write it like this. And now we've simplified this thing. This is the same thing as this right here. Let's clean all this up and let's start over again by plugging in n equals 1, 2, 3, 4, all the way up to 216. For n equals 1, we have the cube root of 1 minus the cube root of 1 minus 1. And then for n equals 2, we have the cube root of 2 minus the cube root of 2 minus 1. And same thing, 3, 3 minus 1, 4, 4 minus 1, all the way up to 216. 1 minus 1 is equal to 0. 2 minus 1 is equal to 1. 3 minus 1 is equal to 2. It'll be 3. 214 215. Now, once again, this means we need to add all of these together. When we do that, this positive cube root of 1 and this negative cube root of 1 are going to cancel each other out. Same thing for this positive cube root of 2 and this negative cube root of 2, and the positive cube root of 3 and the negative cube root of 3. This cube root of 4 will cancel with the negative cube root of 4 that's going to be there, and then everything between here and here is going to cancel until we get to the positive cube root of 214, which will cancel with this negative cube root of 214. This positive cube root of 215 will cancel the negative cube root of 215, and now we've definitely simplified this thing. All of this stuff canceled out except for this and this. So the answer to this sum is going to be the cube root of 216 minus the cube root of 0. Cube root of 216 is equal to 6, and the cube root of 0 is equal to 0. 6 minus 0 is equal to 6, and that is the answer to our question. The sum of these 216 terms is equal to 6. Let's put a box around it. How exciting.